According to Sarah, the writer of a 2017 article posted on freeyourmusic.com, there's almost 30 million songs on Spotify. If you average that to be 3 minutes a song, it would take you 170 years to finish that and to listen through it completely. That doesn't even account for the 20,000 songs added daily. In fact, the amount of audio recorded and saved on Earth since Thomas Edison invented the phonograph is beyond our understanding, and almost too much to guess exactly how much there is. But recorded audio has also been a great benefit to our society, as we now have TV shows and movies that are no longer silent. You can connect to anyone, anywhere via phone or Skype, and you are always just a few clicks away from listening to your favorite artist. I personally listened to 55,000 minutes on Spotify last year, and that doesn't even include the YouTube and the iTunes and all the time that I spent on those devices, those streaming services as well. As someone who loves music and is an engineer, I've always wondered how a record player makes music. To first understand this, we need to know a background in science and physics principles. Then we'll be able to walk through exactly how a record player works and runs and operates. So first we need to look at the physics. We need to understand sound, how it works, what it is, and how it travels. So according to Benjamin Hollis, in a 2017 article posted on The Method Behind the Music, sound is just vibrations. It's just vibrations through a medium such as air or water that form traveling waves, such as in here. They form in areas of decompression and compression. So these darker areas is compression, and the lighter areas is decompression. And it just keeps pushing on in a chain reaction through this medium. Kind of like in the ocean, the areas of compression would be a wave because there's a lot of molecules, and then the trough behind it would be the decompression. And it continually goes until it reaches the surface. These waves travel until they hit our eardrum. According to a 2018 article posted by a Hearing Link, our eardrums are highly sensitive devices that are able to detect these small vibrations in the air. The air hits it and moves our eardrum, and our eardrum, through a complicated process, but one similar to a record player, turns those vibrations into electrical signals that our brain then understands and recognizes as music, or even just recorded audio. Now that we know a little bit about sound, a little bit about how it travels and how it works, we need to understand a couple physics laws that are important to know. The first is Faraday's law of induction. Simply put, it is a magnet. If a magnet, like this hacky-sack, is near a current or an electrical circuit, electromagnet, as it moves around the magnet, as the magnet moves, it creates a current in this circuit. So as it changes position around it, as it moves towards it and away from it, decreasing and increasing speed, as it does all of this, it creates a current in a particular way in the circuit. It just has to be moving, because if it's standing still, it's not producing anything. And it's doing this without touching it at all. This also leads to our next important law, Lenz's law, which are very similar and tie together. But Lenz's law says that this electromagnet, even though it's not magnetic, it produces a magnetic force when the actual magnet is moving near it or away from it in order to counteract it. So as it moves closer, the force is going this way and stronger. The electromagnet produces a force opposite of it in order to balance it and to counteract it, which then allows it to repel or to attract the magnet based on whether it's moving away, whether it's the south or north pole, so on and so on. It's also important to note, as we're talking about these physics laws, that they came from a 2019 article posted on Khan Academy, a very good site for explaining math and physics in simple terms. And it also goes on to talk about how this can work both ways. This electromagnet can be brought near the magnet, can be moved around, or they both can be moving, and that also produces the same effects. So now that we understand our background in physics and sound, we can understand and walk through how a record player works. This information is based on these two articles, one by Meredith Bauer, her December 7th, 2009 article posted on howstuffworks.com, and Chris Woodford's 2018 article on explainthatstuff.com. Both of these are allowed to fact check and to make sure that the process is the same, and they both do add up. But they explain that first part of a record player is the record. It's a major part. It's just a circular disc made of plastic, but it's got spiraling grooves that go in towards the center. It's a little bit hard to see even for the naked eye because they're just so tiny. But the main part about the groove is that it varies in depth, and it varies in particular ways to make the needle, as the stylus that is going around it and tracking in it, vibrate up and down. So a particular depth, particular pattern creates a particular sound. So as the stylus or the needle is following, as the record is spinning, it vibrates up and down, and it's attached to a metal strip. So this metal strip then, as it's moving up and down, it's carrying those vibrations in towards the cartridge, which is the next main part of a record player. The cartridge consists of an electromagnet that is stationary, as we saw, and a magnet that is attached to the metal strip. So as the metal strip is vibrating, it's making the magnet move back and forth near the electromagnet, creating a current in it, like we saw. So it's turning these vibrations into electrical signals. These electrical signals then go through wires and leave the cartridge, go through an amplifier, which just amplifies the signal in order to make it more detectable and easier read in the future, in the later part of the record player. But yeah, the main part, and it's cool to see that it turns vibrations into electrical signals. The next part that the wire and electrical signal goes to after the amplifier is a speaker, which does the opposite of the cartridge. It takes the electrical signals and turns them into vibrations. So, as you can see from this diagram of the speaker, we have these orange wires, which are the circuit in which the current goes through. As it's going around it, it is in near proximity to this magnet. So there's a magnetic force produced in this current because of the current and based on the variations in the current that allow the electromagnet to move back and forth based on whether it's attracting or repelling the magnet that is stationary. So it moves back and forth and very fast, but it's also attached to a cone. Now this cone is important because it is what displaces the air. As the electromagnet is moving back and forth, it pushes the air and forms these traveling waves like we discussed. These waves then go to our ear, like we know, and our brain understands that that is music, the stuff that we like to hear. And that is how a record player turns the disc into music. So we first looked at the background and understood how sound works and understood the two laws that are very important, Faraday's law and Lenz's law. Then we were able to walk step by step through a record player to understand exactly how it works. While technology has come a long way since this plastic discs and records, the underlying principles are all very similar. Even though nowadays we have numbers and code to determine the vibrations, they still use the same for speakers, as in pushing and traveling waves, and also converting these vibrations into electrical signals. But whether or not you were listening to a podcast, your favorite artist, or even a phonograph, hopefully you have a better understanding and appreciation for the sounds around you.